Good morning, viewers. I welcome you all for a lecture session on the topic of gas chromatography. So, gas chromatography, it is a separation of thermally stable and volatile organic and inorganic compounds. And the below diagram shows the various elements of a gas chromatograph. The basic parts of a gas chromatograph are carrier gas supply along with the pressure regulator and a flow monitor for the constant flow of carrier gas, sample injection system for the introduction of sample vapors into the flowing gas stream, a chromatographic column with an appropriate length of stationary phase, and a thermal compartment to maintain the temperature of the column, detection system to detect the various components which elute from the column, and you have a recorder to provide a readable signal which is proportional in magnitude to the amount of each component present in the analyte. And this coming to the carrier gas supply, the carrier gas must be chemically inert, and helium, hydrogen, argon, nitrogen are used as the carrier gases. Helium is preferred for thermal conductivity detectors because of its high thermal conductivity relative to that of most organic vapors. Nitrogen is preferable when a large consumption of carrier gas is employed. And these gases, the flow rate of these gases is adjusted by means of a needle valve which is mounted on the base of the flow meter, and it is controlled by capillary restrictors. The operating efficiency of any gas chromatograph is directly dependent on the maintenance of the gas flow. So, going to the parts of the gas chromatography, we have done with the carrier gas supply, the carrier gas flow regulator. We will be discussing about the sample injection system in the subsequent slides. So, coming to sample injection system, the samples can be a liquid sample, and these liquid sample will be injected into the column through the micro syringe, which is been micro syringe. Can you see here, this is the syringe and the needle, and this is the liquid sample which forces the liquid into the gas column, into the column. Next comes the gaseous, how the gaseous sample can be introduced into the column. That is through this valve kind of arrangement. This is the 6-port valve, and the position of the valve will be changed to infuse the gas into the mobile phase. Gas sample into the mobile phase. Then comes the chromatographic column. Chromatographic column are of two types. One is the packed column and a capillary column. The packed column is made of stainless steel or glass that may be in the form of a coiled, bent or straight. And these packed columns are 1.5 meter to 10 meter in length with an internal diameter of 2 to 4 millimeter. The tubing contains the packing of solid support material which is coated with liquid or solid stationary phase. And the capillary columns have an internal diameter in the order of few tens of millimeters, and lengths are usually between 25 to 60 meter. The capillary columns are usually made of fused silica with a coating of polyamide, and the columns are so flexible that they can be wound into the coils. So, these mobile phase which carries the sample which moves to the column, which moves towards the column, and based on the retention level, the different components will elute at the different times, and the elution of these components will be detected by this detection system, And you can have various detectors can be connected to this gas chromatograph, like flame ionization detector, thermal conductivity detector, electron capture detector, flame thermoionic detector, organ ionization detector, and sulfur chemiluminescence detector. So out of these detectors, let us discuss about one type of detector, that is flame ionization detector. And this just have a look at this diagram, and this flame ionization detector, the element from the column is hydrogen gas is mixed with the column element, and it is fed through this nozzle, and this hydrogen mixed column element is exposed to air and it is burnt. There you have a flame jet. Can you see here, this is a flame jet. This flame jet acts as one electrode, and this collector acts as another electrode. So when these element materials are pyrolyzed at a certain temperature, the ions will be formed. It will get ionized. The materials will get ionized, and these materials and these ions being collected in the collector, and there is a flow of ions causes the electrical signal. So thereby the element components are detected. And this flame ionization detector is widely used because this is useful for analysis of organic compounds, and it is highly sensitive instrument with low noise, high reliable, and it is easy to use with large linear response range. The disadvantages of this type includes mass dependent detector, which means it destroys a sample, and it requires a flammable gas for its detection. Hope Hope you have understood the various components. I'll just go through once. Hope you have understood the various functioning of the principle and the working of each and every component of a gas chromatograph. Hope you will find this video useful. Thanks for watching.